In order to address this lack of asset information interacting with the CostOS proposed route, I have written an API, standing for Application Program Interface, which interacts with the Civil 3D Application Program Interface. So what we're doing is going to be driving Civil 3D from Autodesk via this program here. The program is going to request a CSV file, which will be called this in this instance for the test run. When we have that, it will produce its progress chart. Once it's done its progress chart, it will then ask us where we want to save the information that it has created. So I'll start the program running and explain more about what it's doing. So the program launches Civil 3D, where the module for the program will need to be loaded. This currently automatically triggers the routine to start, but this can be altered if necessary. So this is the DLL module, also known as the Dynamic Link Library. The file that we received initially from CostOS. If I select that, press open, you'll see the progress dialog box is working in the background. So to obtain geographical and infrastructure information, these are using the government's free big data sources. So what it's going to do is overlay the route onto the existing topography from the government, and then from there you can overlay the existing infrastructure networks such as roads, A roads, B roads, minor roads, different sizes of river, and railways. When the program finds a particular asset crossing our route, it will split the route and put bridges there, and then await the user to define what's happening more specifically. You should be able to see what's happening in terms of the profile, how high and low we're going above the ground in real terms, and it should be producing design information also based on the inputs that have been provided. Some of the progress is quicker in stages, as not all the lengths between assets are the same. The program is finished and now is prompting me to save the amended file prior, which will probably go back into CostOS unless we make further changes, because we know that there's optimizations required already. So I'm going to save that file, and then we can go and inspect what's happening within Civil 3D. This is purely an information panel and we don't need to worry about that. In the background here you can see the route, and that actually has had corridors associated with it. Toward the bottom you can see the sections of the route which have been split up by the existing assets. Where you see colours of red and green, these are cut and fill, and instances such as this are actually bridges where something is crossing. It is not just the rail route profiles that we are interested in. The assets across this profile are also split into three. So we'll have what would be the left hand side, the intersection area, and the right hand side. So these groups of three are for each asset. Looking along the route, you should be able to begin to see where the gaps are. So initially we've just taken an arbitrary radius, and that determines what the gap should be, which may not be correct. Looking specifically on this item, you can see that the centre line of our alignment, regardless of any further width that will be added when we build the corridor for this item, we know that at this point we're going to have to change whatever the design is, because the bridge that's going to be required would probably be over 300-400 meters long. So an alternative solution to get this asset crossing our railway will need to be produced. If we look in the corridor features within the tool space and drop down, these exclamation marks indicate the corridors need rebuilding prior to their full interaction to be shown. So I will rebuild these pause the video and bring it back once they appear.